Hey, well, welcome everybody once again to Astronomy Daily Live. A little bit late, a little bit late. Yeah, I was running a little bit behind. I had to set up the telescope outside, so that delayed a series of events, which which sort of pushed the beginning of this live stream. Uh, into the realm of having to hurry, right? Having to hurry. So I'm like, okay, I'll just, put this off, for 10 minutes. That's more than enough time, right? So that was fine, right? I mean, I sent a message over to my Discord server. I sent a tweet out. It's hard to do rapid communications, so you just have to uh, if you're not on my Discord server, you should definitely get on that. Or if nothing else, get on to Twitter. Um, I usually post updates there in terms of being late and that kind of stuff. So I'm thinking about getting a Instagram as well, but I haven't made that leap yet. Anyway, so all was going just fine, right? It's like I had actually uh, started, the Hangout. I hadn't pushed, the go live button yet, but I've started the Hangout, and I look up and I notice that there is absolutely nothing I can do. I've got a mouse moving around, and that's it. It's all there was. So I'm like, oh man. So yeah, it's like 2:07 UTC, right? And I wanted to start at 2:10, and it's like, at 2:07, this you know dumb computer decides to just completely freeze, right? So it's like, oh man, okay. So I had to do the uh, I guess you call it the hard reboot, right? Where you hold the power button in, for 5 seconds, and it goes off, right? But every single time I do that, I just absolutely cringe, right? Because it's like, man, this thing is not going to come back on. So, but so far it has, and it is definitely, it's something in Chrome that is just bringing my system to its knees, and I sort of blame bad programming on that, especially all. I mean, every almost everything behind the scenes now is JavaScript, right? You going to bed? Night night.
See it. Oh.
All right, we got that
Got
one.
out.
We got you.
You got us.
We got you.
Oh, lovey dovey.
Hey,
We'll
darn
have to
you,
put.
Dizzy Sue.
We'll
Good
have
night,
to put that.
darling.
We'll have to put that on a T-shirt.
Ugh.
Well,
I would say my apologies, but it did seem to entertain you, so that's not a problem.
absolutely not. So, Tim, what else is going on over there?
Over here?
Yeah.
Not a lot, really. Why?
Just asking.
I thought there was something going on behind me. No,
No.
apart from the cat sleeping down. Oh, he's not sleeping now. He's looking round. But apart from that, nothing else happening at the moment.
Good.
How's you anyway?
Everything's good. Everything's good. Bobby, what's going on over there? You're jumping out of the screen.
I'm jumping out of the screen. Well, thank goodness that Tim scared you and not me this time.
No, you guys are gonna have to work much harder than that. Yeah, for sure. So yeah, all is well here. I'm gonna look in on the chat really quick. So yeah, my huge apologies for being not only late but very late. But yeah, these computers, they just decide to do things sort of on their own, and just gotta go with it. I did a reboot, pop back in. Here we are. Case closed. No problem at all. So, all right. Well, I hope everybody's doing well. So, let's say, definitely want to say hi to everybody in the chat. So, Carolina Sky Astronomy, Jim. Hey.
Chuck,
Ingrid, if you're still there, Chuck, Tom.
Oh, it's Tom there. I'm sorry, I missed you, Tom. I apologise for not replying in the.
Yeah, there he
messages.
is. There
Hello,
he
buddy.
is. Yeah. And let's see. Yeah, just looks like the regular great crowd. So very cool. Very cool. So yeah, it's I got off of this live stream yesterday, and I'm like, okay, I have to decide in the next hour whether I'm going to observe this eclipsing binary star or not. And
did you flip a coin?
I didn't even get as far as flipping a coin. I just completely wimped out and was like, nah, I'm just not going to do it. I'm just not going to do it. And I knew at the time, I'd be like, look, dude, right? You're going to wake up in the morning and you're going to be like, why didn't you do that? Right. And that's exactly what happened this morning. It's like, no, dude, just do it. Right. So it's, it looks like it is clearing up here again tonight. So as you can see, I don't have any telescope behind me. That's because it's already outside, which was part of the delay in getting the live stream going. Is that it takes about I don't know, 15 minutes or so to set up the scope outside. Got to plug everything in, make sure everything's on, change all the settings, whatnot. So yeah, ready tonight for actually another eclipsing binary star. This one is named GQ Tau. So it's in the constellation of Taurus, and it's just called GQ. These stars have, well, there are lots of names, right? Most of the variable stars have some, sort of among, the many others. Most of the, at least the brighter variable stars have some kind of letter designation, like R Leo, right? Or yeah, those kinds of things. Well, this is the same thing, except it has two letters, right? G and Q. So it's way up in the constellation of Taurus, about as far north in Taurus as you can go. It's just on the boundary between Taurus and Auriga. So it's pretty high up in my sky, but it's about as high as it's going to be. So it's going to be coming down, heading west.
No.
So yeah, I am going to track that dude for, I don't know, 3 or 4 hours, something like that. It's a fainter variable star. I think the brightest it gets is well, we can actually just go and look. So let's do that. I was over here. Yeah, I actually got myself back onto the AAVSO website. So let's pop over there and just take a look at this eclipsing binary star.
At least Chrome does to give you a recovery option.
What's that?
Chrome gives you a recovery option.
Yeah, sometimes I choose those, and sometimes I don't. If I have a crash, I'm like, well, why do I want to revive something that is going to crash my system? So sometimes after a crash,
Hey, Ingrid.
I don't have to do any of that. Is Ingrid back in? Cool.
Yeah.
All right, so we're going to go to the variable star index. We're going to do a search for GQ tau is already in there. Wow, surprise, surprise. So let's take a look here. So this is just sort of the basic info, right? The constellation and the coordinates in the sky and proper motion, other names, right? They always have other names. So this is at least the primary star is a B9 star. So that's a pretty luminous blue star, probably pretty massive. Doesn't have any info about the secondary star, but it's a secondary that actually makes this kind of thing all go, and we see, you know, a drop in the magnitude when the secondary star, the B component, you can call it, I suppose, actually passes in front of the primary star from our line of sight. It's just like a transit, right? In fact, you know, you could call it an eclipse. I guess it's an eclipse. You could call it a transit if you want. You could call it an occultation if you want. Those terms are sort of, you know, almost synonymous, almost. But I guess they like to call these eclipses, right? Because this is an eclipsing binary. So it does say that it has a period of 1.53 days. So just over like 36 hours or so for the secondary star to go once around the primary star. So that, you know, I still have a hard time imagining that, right? I mean, it takes Mercury 88 days to go around our sun, right? But here, not only is the period, you know, 1.5 days, but you're talking about a star moving like that. So I just can't imagine. I have a hard time imagining what that would actually look like, right? You know, if we were on either some kind of ship or some kind of planet or something, seeing this, it would, yeah, I don't know, that would just be crazy. But there's thousands of these things, right? They're all over the place. So pretty amazing. And you can see they have an ephemeris here that, in this case, is just showing the predicted midpoints. So as you can see, there's one here at 429 on the 19th. It is currently 2:28 UTC. So it's got about 2 hours until it gets as faint as it's going to be, and then it's going to start brightening up again. So as you can probably tell, I'm pretty anxious to get out there and start collecting data. I think I'm more or less, at this point, I'm past the astronomical twilight, so it's about as dark as it's going to get. I've got the moon out, but that's one of the cool things about variable stars, is that you compare the brightness of the variable star to a nearby star. And in fact, I've got that in this case. Let's see if I can find it here. let's see there. We go to variable stars, GQ tau. I think I just made a new chart here, a finder chart. So this is, I believe, yeah, a 2-degree radius, right? And I guess it isn't exactly a radius. It's more like a rectangular shape, but it's 2 degrees. Actually, I guess 4 degrees on a side. Is that right? 2 degrees on a side. Yeah. We can look at the bottom here and look at the declination. The middle, or I'm sorry, the right ascension, 85.5, 86, and 86.5, I guess, is a little bit out of view. So yeah, this is a full 2-degree radius field of view here. And I've got my little purple box centered on the target at hand, which is this guy right here. So this little dude right there is GQ tau. And as you can see, in my field of view is going to be a nice bright, I think it's like a magnitude 8.6 star, which I've confirmed isn't a variable star as far as we know. And so that I will use as a reference, right? This will be staying exactly the same. This should be varying in brightness. I might be able to use this one too. It's a little bit fainter, but not too bad. So yeah, so that's the finder chart that I'm going to use, because when I point the telescope, I could literally be pointing anywhere here, right? So what I have to do is I have to, tell the telescope where it should point. It's going to go and point wherever it thinks it needs to, which, as I said, could be anywhere here. And then I have to identify that field and nudge the telescope over until I see that. So, and that's my field of view. This is 12 arc minutes this way and 9 arc minutes that way. So I think one of these squares is like 1/2 of a degree square. So the full moon would fit in this one square, right?
There's a lot of stuff in one square, isn't there?
Yeah, well, these are only the stars down to 15th magnitude, right? Gaia.
So there's a lot more.
There's a heck of a lot more. Gaia goes down to 22nd magnitude. So yeah, this I think this field has something like 15,000, almost 16,000 stars in it, and that's only down to 15th magnitude. So yeah, there's a lot of stuff out there. I mean, I'm telling this is one of the things that I say over and over and over again. There's a lot of stuff out there. We are not living with things not available. There's a lot of stuff out there. So we have an abundance all around us. We just have to figure out how to get it. But anyway, so that's my target for today. And as you may have seen, where's the? It looks like the magnitude range goes from 11.2 to 12.2. So that's a whole magnitude, which is really, really nice. I don't think that there were any AAVSO light curves. Don't think so. No data found for this star, but there were some other light curves. The ASAS light curve, ASIS. They had a couple of light curves here, as you can see. Kind of hard to I guess that's not bad, but you can sort of see. So this is in terms of orbital phase, right? So from 0 to 1 would be one orbit. So as you can see, you know, this from this minimum to this minimum is one orbit. So that's how they are measuring that. Not quite sure what the difference here is. Yeah, not quite sure. I guess this is, oh, okay. I think I'm understanding this maybe. This is the actual data, right? So this is the some kind of Julian date, and it's over, wow, you know, several thousand days. So this is all the data they have. This is in terms of orbital phase. So that's kind of cool. I don't know if you can notice this or not. It's not incredibly obvious here, but I will point it out anyway. Do you see this little sort of a dip here? That's a real thing too. That's when the secondary mirror is at.
There is more out
mirror.
there than we can ever explore in a lifetime, saying Jim.
Oh yeah, yeah. No, I mean this is very, very true. There is so much stuff out there. It's just
and Tim could have said that in the panel side. It's astounding how much more that is that we can't or don't see.
Yes. Yeah, well, see, that's just it. You know, that's what keeps me skeptical, right? Is this realization that I don't know what I don't know, and when you realize that, you know, you've got to be skeptical of things. Yeah, for sure. Anyway, so looks like a pretty nice thing. Oh, as I was going to point out, when the secondary star is moving behind the primary star, there can also be a little dip in the light curve as well. It's really hard to see here, you know, because the data is noisy enough. But that's probably, there's a little bit of reality in that one, right? That is definitely not the best one I've ever seen, or the deepest one, right? Sometimes these things can actually go pretty darn deep. But yeah. So it looks like it varies by about a magnitude or so, which is a factor of 2.5. So yeah. So that's what I'm going to be looking at tonight. I was sort of looking at this width here and determined that was something like about 5 hours or so is the entire eclipse. So, you know, if the midpoint, where is the midpoint? If the midpoint is at 429, then it's essentially already started as of right now, and we'll go for about 2.5 hours after this, right? So yeah, it's well, we'll see. You know, the only thing I can do is collect the data, not wimp out, and just do it. So that's what that's all about today. Let's take a look at. There's not a lot of info about this star over on Simbad. GQ Tau. So it too says it's a B star. That's good. I'm going to be looking at it with my green filter, which is very, very close to the Johnson V. This G, I believe, is probably Gaia G. But yeah, so I'm expecting that at its brightest, it's going to be about that, and at its faintest, as I said, it's supposed to drop about a magnitude or so. So yeah, and it's, well, it's just a look at the image over here. It's just a, you know, just a normal star. I actually looked up also the information about this star, which is going to be my reference, right? So I'll be able to see, hopefully, I'll be able to get both stars in on the same field of view, right? That's sort of the plan, and that's why the moon doesn't matter all that much, because I'm doing a differential thing here, so doesn't matter much. But yeah, so I should be able to get both of these in here. This star turns out to be a G5 star. So our sun is a G2. So these this star and our sun are sort of similar. And you know, even from this not too great color image, you know, because I think it's being a little bit overexposed there, but you can definitely tell that it's a nice sun colored star. You know, I mean, this guy is definitely blue, right? And that one, but this guy is definitely sort of a yellowy, orangey red, which is what you would expect with a G star. All right, so there it is. You can sort of, we can look at the chart, and you can see that it's all sort of here. Let me move this over a little bit. Go like that.
Twin sun, maybe.
So as you can see, here's the bright one right here, right? And then here's our target star. That's this guy. And here's this guy over here. And then you can see like this little triangle here, stars. That's these three right here, right? And then there's another one over here, this guy. Those two guys. There's a really faint one up here. This one. We got a bright one next to a faint one. That's these two. So yeah, they're all there. And as you can see, this is actually seeing fainter than 15th magnitude, right? The smallest dot on here is 15th magnitude, right? So I think this guy here, which hopefully is going to be my reference star, as I said, I think is about magnitude 8.6 or so. I haven't looked to see what this one is, but it's probably, you know, if this one is coming off at what, like 11.2, 11.3, then this one's got to be maybe 10.5 or so. So yeah, I mean, I'll definitely be able to see all the stars in that field, you know, with a 4 or 5 second exposure. Yeah, no problem. No problem. So yeah, as I said, there's not a lot of info on this guy. It's got a few names, as you can see. But references are pretty sparse, right? They're more of just like catalogs and timings, right? The predicted times of minima can actually be different than when, you know, the actual minima are observed, and there are lots of guesses in terms of what could cause that. But of course, one of the things that can cause that is a third body or a fourth body or a fifth body. that can, you know, just slightly change the orbit a little bit. And so, you know, that allows us to sort of, you know, peer into those kinds of possibilities. So that's why publishing these ephemerides are really, really useful, because when you go and observe them, if there's a difference, well, that is telling you something. Yeah, so here's some more. I don't know, IAU information bulletin on variable stars. I don't know if this will have any downloadable thing here or not, but maybe we can just look at it really quick like. Oh, it is available. I don't know what it's going to look like. Oh, uh-oh.
What the heck?
Yeah, that happens. Let's try this out. All right, well, that one's gone. I'm not going to try too hard on these guys. So yeah, just a variable star. Well, an eclipsing binary star. So that's the one that we just did. Selecting maximum pulsating stars. Same journal, so I don't know if it's out there anymore. Here's a catalog of Algol type binary stars. Algol, of course, is one of the eclipsing binary stars that you can see with your own eyes, and actually see this thing dim and brightness over the course of a couple of hours or so. And the minima of Algol is a published and known thing. I think like Sky and Telescope magazine, I think they publish a minima of Algol every month.
What if there's a star named 404?
There's probably a lot of stars named that. Semi-detached binary stars.
Yeah, but is there one called File Not Found?
Let's see. Serial number. Probably not going to list them all here, but they might. No, they're not. They're listing it somewhere else. So let's see if we can. I wonder if that listing still exists. That would be pretty funny. Catalog of 411 Algol, presented in a form of 5 separate tables of information. Okay, where? Here it is. Wow, so I wonder if this still exists. Let's try it. Yeah, there it is. So let's see. How do I? There it is. Table 1, Table 2, Table 3, Table 4. There's a 6A and a 6B and a 6D and a 6C also. Cool. Let's see. See if we can save this somewhere. Well, we'll save it in the usual way here, 190319. Save it, and let's take a look at it. I need a terminal. Astro Live 190319. Oh. All right, so I'll make this really big here. Okay, well, we have to have an explanation as to what all these columns are, but obviously this is the right ascension, declination. Looks
Yeah,
like
they
some
could have
kind
told
of...
you something like that.
Well, they probably do in the text. These are different surveys, right? The Hipparchus, Tycho. I forget what GCVS is. So there they are, 400. Well, there's 435 total lines here. 435. Didn't they say there were 441? 411. So they say 411, but there's 435 lines. Well, whatever, I guess.
What did they come up with those extra lines for?
I don't know. It's just kind of strange things that sometimes there don't seem to be any kind of resolution there. Okay, so let's see what this table 1 talks about at least. Table 1, serial number of the entry, name of the star. Okay, so we've got serial number of the entry, right? Which is like, well, here let's find our guy, GQ tau, number 387, right? Then they're talking about the name of the star, right? GQ tau, some kind of names, right? Different names, different catalogs. So yeah, right ascension, declination, and then the semi-detached status. This was a crude probability indicator. 2 point generally. Okay. I think I have to. It took 5 values, 0.1 up to 0.9 in steps of 0.2, 0.9 for well-known examples, 0.7 for binaries of apparently similar properties to the 0.9 cases, but generally less well-known, 0.5 for binaries. Okay. Interesting. So, okay, so that's what that is. And then, yeah, that's just the catalog reference. Okay, so look, table 2 is going to give us a little bit more photometric information. Cool. Color, orbital period of the binary. Yeah, so they've come up with a lot of information just based on those light curves, right? It's pretty amazing what you can do. But yep, it's possible to get all those different parameters, or at least have a model that when ran produces similar data. So let's look at table 2 really quick. That seems to be maybe the most interesting one. So table 2 over here, where are we? Table 2. Table 2 coming up.
Coming up, B.
Go. Spread this out a little bit. There we go. So GQ tau. Yeah, so they're saying that it's brightest, right? I think that's how I'm reading that. I'm gonna go back over here. Yeah, so maximum brightness, and then the change in magnitude, right, between as faint as it goes and as bright as it goes. And as you can see, it says 11.2, and a difference in magnitude of 1 magnitude. So cool, nice. Oh, and here's the period, right, in days, 1.53, which we already knew. I don't remember what these numbers are. Name, 2, 3. Let's see if we can figure out what this is here. So the next one over is color, which we don't have a color, right? There's nothing there in that column. The next one over is the wavelength of the light curve to be associated with the photometric solutions. That also isn't there, right? The next thing is a P, epoch of the primary minimum of reference.
Is that your dog, Bobby?
Yes, sir.
Cute little one.
Is that Blackie?
Yes, sir.
All right.
I'm trying to decide which one's better looking.
Take your
Thank you,
time.
Ingrid.
Take your time.
Jim must know what's tau mean.
Tau, that is the constellation reference, Taurus. Yeah. So, yeah, I'm not quite sure what that number means. It's epoch of the primary minimum of reference. Yeah, I'm not quite sure what that is. All these numbers are really, really different. So, but anyway, yeah, there's some useful info. I think it's pretty remarkable.
Cool dog.
This paper came out in 2003, and that data is still online. So definitely hats off to these guys. These are the Sinbad guys. They hold on to everything. So yeah, it even looks like these things were published back in 2004. So.
And that's why I need to get a Bluetooth headset, because right now it's been tripping on that cable.
Yeah, they like doing that.
Well, that's an interesting snippet that Tom's put up.
Oh, let's see what.
Yeah.
Let's see what.
Yeah, check it out.
Let's see. On this day, 1965, Alexei Leonov stepped outside of the Voskhod 2 to take the first ever spacewalk. Yes.
Very cool.
Had some trouble getting back in, though. Wow. That could be kind of nerve-wracking. Would definitely say, but yeah, it's it has been a while since we've been doing this, so yeah, very cool.
I think he should change his name from Tom Van Scotter to Tom Van Encyclopedia. He's a brilliant guy, honestly.
Absolutely. Well, yeah, that's this is sort of a big year too, as far as space goes. This is the 50th anniversary of Apollo 11. So that's coming up in a couple of months. The one thing, speaking of nice things happening, I was alerted, and I don't know why we didn't see this when we were looking at the astronomical events for the month of March. But I'm going to go back over to Cloudy Nights really quick. And I want to see.
Probably still in college back then, huh, Patrick?
Hello,
March
Mr.
20.
Patrick Manny.
Hey there, Patrick. Okay. Here we go. So yeah, it was there, and for some reason, I totally the coincidence. So as you can see, on the 20th, we go through our vernal equinox at 21:58. So late on the 20th, right? Late. Well, very, very early on the 21st, namely what? 4 hours later, 5 hours later? Is it 5 hours later? No, about 4 hours later, 4 and some change hours later is full moon. So the vernal equinox and the full moon are basically occurring at the same time. So I thought that was pretty cool. I didn't notice it when we went through this the other day, but yeah, that is kind of a nice coincidence. That definitely doesn't happen very often. Now, is there any other kind of significance? I don't think so. I just think it's really, really neat that they just so happen to almost exactly the same time, right? Within 4 hours of each other. That's a pretty good alignment. So yeah. I just thought that I would mention that really, really quick. And I think that I'm kind of itching to get out there under that black sky. Let's do one more thing really quick. We can go over and we can look at my cloud situation together here. Hopefully this won't bring the system to its knees. Had a little bit of buildup during the day, but those kinds of things tend to evaporate once the sun starts going down. And oh yeah. So I'm about here, right? So you can see that I've had clouds a lot of the day, but look at that, it's just vanishing. Now there's still some clouds here, so I don't know what they're going to be doing. So the only thing I can do at this point is go outside and look up. I've got the moon there, to brighten up the clouds. So at least I'll be able to see them if they're there. So, all right, well, I think that's exactly what I'm going to do. I'm going to make this a shorter than normal live stream just because I'm starting a little bit late and sort of itching to get out and take some data with this eclipsing binary star, GQ TAW. So I think that's exactly what I'm going to do. I'm going to get on out of here. See if there's anything else in the chat. Yeah, I was in July 1969. I was 9 months old. So I was told that I actually did see it, but no, sorry, I definitely don't remember those kinds of things.
So we're both in the 50 club.
Oh yeah. All right, everybody, I'm going to get out of here for now. I don't know where Bobby went. He sort of
he's disappeared.
He sort of disappeared, but yeah, he says whoops in the chat. But yeah, I think it's about time that I get on out of here. So thanks everybody again for coming in. I do this every single day, more or less the same time. 2 hours UTC is when I normally get started. Sometimes there's a little bit of variation there, but yeah, just a really short one. Bobby's going to pop in anyway, just for fun.
There he is.
Yeah, there he is.
Or he
but
seems
I'm gonna.
to be.
There he goes. But I'm absolutely going to get out of here. So thanks everybody again. Make sure to hit the thumbs up if you haven't already. If you so desire, make some comments. Spread the word. We're just talking astronomy here. Astronomy, space, science.
Not what I'm going to do. That's not what I want to do. I want to open a new tab and get me to the email.
All right, you guys. Well, I'm going to get out of here. So I will see you in a little less than 23 hours from now. All right. Take care, everybody.
Thank you for your time and effort, Matt, and happy hunting tonight.
Live long and prosper.
It'll be fun. All righty. See you later. Bye.